Good morning, dear friends. The last session we have seen what is mean by electromotive force and what is mean by potential difference and what are all the loads are available. We have seen the different types of loads. That loads are resistive load, inductive load, and capacitive load. Based on the characteristics of the load, that entire circuit parameters will be changed, especially current, everything will be changed. So today's session we are going to learn about what is mean by resistance. Already we know the resistance is nothing but it will oppose the flow of current. Normally resistance is will oppose the flow of current. Let us see the analogy now. Assume there is having a pipe and the water is flowing, but there is more number of stones are inside. Stones are we put it inside. So that time water flow will be reduced, and so that we can see it will resist the flow of water. Similarly, in the conductors, when the resistance are increases, it will oppose the or resist the flow of current. So automatically the current flow will be reduced. In other case, when in the same pipe the stones are reduced, that time water will not have much resistance to flow. It will flow very easily when compared with the previous one. So similar way, when the resistance are less, or the current flowing will be more. So ultimately resistance will oppose the flow of current. If the resistance increases, current will reduce. When the resistance is reduces, current will increase. So this is the ultimate concept behind the resistance. So when we analyze the resistance having four parameters to control. So let us see the one by one. First, assume that in this, when the length of the conductor is increasing, the resistance value will increase. When the length of the conductor reduces, resistance will be reduced. So from this we can conclude resistance is directly proportional to the length of the conductor. Then let us see the next scenario. When the area, this conductor is normally, wires are normally cylindrical in shape, right? When the area of the conductor is more, current flow will be more. Then when the area of the conductor is less, current flow will be less. In alternative way, we can say, in other way we can say, when the area is more, resistance will be less. When the area is less, resistance will be more. For example, in the wide area, the cars will, all vehicles will move fast. At the same time, the narrow area, the vehicle will not move fast. Same way only, in the wide area conductor, electrons will move fast. In this narrow area, in this very less narrow wires, we can say that very width is very less, the area is very less. That type of wires, the electrons will be move very slow. So we can conclude from this the resistance is indirectly proportional to the area of the conductor. As the area of the conductor increases, resistance will be increase. Resistance will area of the conductor is increases, resistance will reduce. When the area of the conductor reduces, resistance will increase. Then third one will be the resistance with respect to temperature. Normally, when we heated up any conductor, there is having the vibration inside the molecule, so it will increase the resistive effect. Increase the resistive effect. So when the temperature increases, which will increase, the temperature increases, the resistance will increase. So from this we can say, but the resistance is also the function of the temperature. Resistance is also the function of the temperature. So from this all we can conclude that resistance is directly proportional to length of the conductor and inversely proportional to area of the conductor. Therefore R is directly proportional to L by A. So we have the constant of proportionality, that is called as resistivity rho. The resistivity unit is ohm meter. Then if you see this, I have seen this this one about the resistivity from the one of the website which I have shown in below. we can see there conductor resistivity and insulator resistivity. In the conductor resistivity, if you see here, that is in terms of 10 to the power minus 6. At the same time, insulator material is having 10 to the power 11 to 17 variation. Variation is between, resistivity is between 10 to the power 11 to 10 to the power 17. But at the same time, conductors are having only 10 to the power minus 6, the very much less resistivity. So the resistivity is less, automatically resistance is less, so current flow will be more. That's why conductors are having very less resistivity, current flow is good. At the same time, insulators are having more resistivity, therefore current flow will be very less. So then let us see about that equivalent circuit of the equivalent resistance calculation, equivalence of the resistance when it is connected in series or parallel. Assume normally the resistance symbolic representation is like this as shown in the figure. When these two resistance are connected in series, when the two resistance are connected in series, that equivalent resistance R equivalent is nothing but R1 plus R2. Assume we have n number of resistance are connected in series, therefore R equivalent is R1 plus R2 plus etc. up to Rn. That means when the resistance are connected in series, resistance will added up, therefore the sum equivalent resistance will increase, current flow will reduce. At the same time, if these two resistance are connected in parallel, assume these two resistance are connected in parallel, that case if you see this here, one small typo error. So if the two resistance are connected in parallel, we can say the equivalent resistance will be R1 by R equivalent equal to R1 plus R2. Then if you take LCM and everything, the final value of R equivalent will be R1 plus R1 R2 divided by R1 plus R2. From this two example, we can conclude with one small, for example, for instance, we assume that R1 equal to 2 ohm, R3 equal to 3 ohm. So if both the resistance are connected in series, R equivalent equal to 2 plus 3, that is equal to 5. At the same time, two resistance are connected in parallel, R1 R2 divided by R1 plus R2. So that means 2 into 3 divided by 2 plus 3, that means 6 divided by 5. We will get approximately 1 ohm. So that means when the parallel connection reduce the resistance, series connection increase the resistance, right? Then assume now we have three resistance are connected in parallel. We can say 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here also that this is first resistance is R1. There is a typo error, R1, R2, R3. Therefore, final equivalence R equivalent is equal to R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R1. If suppose n number of resistance in connected in series, parallel, we can say 1 by R equivalent equal to 1 by R1 plus 1 by R2. Then one can try with many number of resistance and you can find out R equivalent after calculating the LCM. So with this we are concluding the today's session. We have learned today what is meant by resistance. Resistance is nothing but it will oppose the flow of current when the resistance is directly proportional to length of the conductor and inversely proportional to area of the conductor. Constant of proportionality is called as resistivity. When the resistivity is increases, resistance will increase. That's why insulators are having more resistivity when compared with the conductor. The conductors are having the resistivity of 10 to the power minus 6 range. At the same time, the insulators are having more resistance, more resistivity with the range of 10 to the power 11 to 10 to the power 17. So then when we connect the resistance in series, that equivalent resistance effect will be increased. When we connect the resistance in parallel, equivalent resistance will reduce. If we want to reduce the resistance effect, we have to connect the conductors in parallel. At the same time, when we increase the resistance, if you want to increase resistance, we have to connect the conductors, effective series resistance effect, we have to connect the conductors in series. So with this we are concluding today. The tomorrow session we are going to learn about what is mean by inductance, and before learning inductance we should understand what is mean by Faraday's law and what is mean by Lenz's law, and how one can derive the inductance, and also when the inductance is connected in series and inductance is connected in parallel, what all the variations are there, all those things we are going to learn. I hope this topic is very much interesting, and those who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.